Welcome to PRO 258, Chapter 8. So this is where things get a little more exciting in statistics class because now we're actually going to begin statistical analysis. The first 7 chapters introduce material and concepts that are critical to understand in order to help you determine what statistical test you should use and how you should interpret the results from those tests, and also to help you understand what the limitations or incorrect conclusions could be as you do apply these tests. So we're going to start with the chi-square test, which is one of the simplest tests in statistics. It's a statistical test that's used to examine differences between 2 independent or more than 2 independent groups when the outcome variable is at a nominal level. So there's a couple key points in this. That first of all, the groups you're comparing have to be independent. That means they can't have any relationship to one another. It may be patients on 2 different units, it may be men and women, it may be different racial groups, but the groups are not related to one another at all. And your outcome variable, which if you remember from Chapter 1 is your dependent variable, is at the nominal level. That means it just has a difference. It's not rank ordered and it doesn't have equal intervals. So when we're looking at a chi-square, it's always helpful to look at a 2 by 2 table. So I would recommend that you open your textbook to page 107 to figure 8-1. And we're going to use this example as we walk through what a chi-square is about. A chi-square simply compares the frequencies that are observed with the frequencies that would be expected if the 2 variables were independent or had no association. So if your independent and dependent variables were not related at all, you should see a value in each of these squares that may or may not be different from the one that you actually do see. So let's start with our null hypothesis. The null hypothesis is that there's no difference in the need for a postoperative transfusion among men and women. Remember, your null hypothesis is always no difference, no association, no relationship. It's the negative. We don't see anything there. Our alternative hypothesis in this example would be the need for a postoperative transfusion is different for men and women. Now, if you look at figure 8-1, you can see when we look at these 2 variables, our independent variable is the gender, whether the person is male or female. Our dependent or outcome variable is whether or not they received a transfusion. So we put them into a 2 by 2 table, and when we did that we found that 20 men were transfused, 30 women were transfused, 30 men were not transfused, and 20 women were not transfused. And then we add up our column totals. However, one of the things that you're going to start to hear about in statistics is something called degrees of freedom. Now, the degrees of freedom for the chi-square are pretty simple to calculate, and we're going to do that in a minute. But the concept itself is a little foreign for most people, and quite honestly, I have to say I grapple with it still sometimes. When you have large samples, degrees of freedom becomes something that you don't have to worry about too much. But when you have small samples, it's still something that's important to be aware of because it does affect your results. And before you determine statistical significance from a chi-square, you're going to need to know what the degrees of freedom are. Degrees of freedom simply means the values that are free to be unknown. So if you look at figure 8-1, once we know the row and column totals, so the A plus C and B plus D, A plus B and C plus D, once we know that information, those totals, then it says how many of those values in the 2 by 2 portion of the table in the A, B, or C, or D box are still free to vary. So once we know what A plus C and B plus D and A plus B and C plus D are, we only have one more value which is free to vary. Because once we know the value of any of the boxes, A, B, C, or D, any of the white boxes in figure 8-1, we can determine the value of all the rest of them. And so that's simply what it means. Any 2 by 2 table is always going to have 1 degree of freedom. But the way you calculate the degrees of freedom for a chi-square test is to take the number of rows minus 1 times the number of columns minus 1. So in this situation, it would be 2 minus 1 times 2 minus 1, or 1 times 1, which is just 1. Now, if instead of comparing transfusions by gender, we might compare transfusions by race, and we might have 3 races, then we would end up with 3 columns and 2 rows. So we would have 2 minus 1, which is 1, times 3 minus 1, which is 2, and in that situation we would end up with 2 degrees of freedom. It's really a concept that you can spend a lot of time going into, but what I want you to understand is that you just need to determine it in order to be able to figure out, do you have statistically significant results? And it's a concept that as you get into larger samples is not as important, but while we are still dealing with some smaller samples, it's important to know degrees of freedom is just the number of values that are free to be unknown. Okay. So if we get a significant p-value, remember that means a p-value less than the set alpha, then the null hypothesis is rejected and significant differences exist. So if in this example, like where we did with men and women, we get a p-value that's less than our alpha. So if our alpha is 0.05 and our p-value is 0.03, then we would say that there is a significant difference between the number of men and the number of women who need transfusions postoperatively. However, I want you to understand that the chi-square doesn't tell you where the difference is, just that there is a difference. So if you find a statistically significant difference, then you need to go back and look at those numbers. So if we found a statistically significant difference with the numbers that we have in figure 8.1, we could go back and say, wow, we saw much higher transfusions, more women had transfusions than men had transfusions. And so if it's statistically significant, we still have to go back and look at our numbers and the data itself to determine what the significant difference in the groups is. The chi-square doesn't tell us that. There's 3 times when I want you to be aware you have an outcome at a nominal level, but you really still should not use a chi-square. So most of the time when you're comparing independent groups and you're looking at an outcome variable that's at the nominal level, the chi-square is the test to use. However, when one cell in your 2x2 table has a value less than 5, and if you look back again on page 107, figure 8.1, your 2x2 table is the white squares, A, B, C, and D. If any of those values are less than 5, you should not use a chi-square test. You should use a Fisher's exact test instead. And we don't cover that test itself in this class, but it's really just to let you know when you get to very small cell counts, that's what we refer to that when we say one of those white boxes is small or less than 5, we start to get errors in the results from the chi-square test. The other thing is when the cell has more than 5 but it's still less than 10, you're going to need to use the Yates continuity correction with the chi-square, and that I want you to be aware of because the SPSS data that's outputted will show you the value with the Yates continuity correction. So you're going to need to know to use that if one of those cells is less than 10 but more than 5. Again, when you get into very small samples, you have to be very careful. Your statistics sometimes runs into issues because the numbers get so small. The other time that you would not use a chi-square when you have an outcome variable at the nominal level is if the samples you're comparing are not independent. For example, in this figure 8.1 on page 107, the example we're looking at right now, the men and women in this study have no relationship to one another. So they are 2 independent groups that are being studied. But if instead we were studying men and women who were married, so by the time when we selected one to be in our study, the second one was automatically enrolled or eligible to be in the study, then we wouldn't have independent groups. We would have dependent groups. If the groups have a relationship or are by selecting one you automatically select the other, you have dependent groups, and if your outcome variables at the nominal level with dependent groups, you need to use the McNemer test instead, not the chi-square. So these are just 3 situations where I want you to be aware of that you shouldn't use the chi-square with an outcome variable at the nominal level. That concludes Chapter 8. You now have the opportunity to do some practice exercises in the book, which I highly recommend. I also would recommend completing your computer application exercises. Lesson 4 in SPSS is available on the website for the textbook, and that will show you some SPSS output to look at so that you can start seeing how the computer reports chi-squares and what that information means. There's also a research article review questions available on the website for Chapter 8, which gives you another opportunity to continue practicing. Now in my class after Chapter 8, I also have the midterm exam coming up, and what I have done is posted Review questions for the first 8 chapters with the answers, which gives you an opportunity to practice those before you take your midterm. I highly recommend covering the answers, taking those questions, taking them, trying to determine what your correct answer is, and then checking yourself. But don't look at the answer before you've tried to think through the question and why that would be the answer. The other thing I found really helps my students be successful on the midterm is to make sure they've done all the homework. The more you grapple with this material, the more you realize what you understand and don't understand, because applying it is much more difficult than understanding it when somebody's telling it to you. The other thing that works very, very well for people are study groups, because you have to start thinking through why those answers are correct or incorrect and trying to understand the thought patterns behind them. And in a group, it tends to be even more effective. So going through those multiple choice practice questions before the midterm is usually a very good preparation for actually taking the midterm exam. Good luck, and I will see you back for Chapter 9.